The topic of this video is the electronic structure of materials. And we start off with the most basic model of the atom, where there's a positively charged nucleus surrounded by negatively charged electrons. Since negative charges are attracted to positive charges, these electrons are essentially trapped within their respective shells. According to quantum mechanics, there are only fixed energy levels where these electrons are allowed to exist. And these are the ones currently populated by these electrons. But beyond these energy levels, outside of the atom, there are also other energy levels where the electrons are also allowed, but there are just not enough electrons to fill them. The outermost layer of electrons are called the valence electrons, and these are, since they are they're furthest away from the positively charged nucleus, they are most weakly bonded. So if you provide some energy, you can actually knock one of these electrons out into this one of the higher energy levels. If we graph this out with the y-axis increasing in energy, these energy levels that are currently populated by electrons are rather close together. So close that electrons basically can freely move up and down, and they essentially form what we call a band. Since the highest energy level in this band is the valence electrons, we call this the valence band. These unpopulated allowed energy states are also fairly close together. And since when an electron gets knocked out into one of these outer shells, the electrons can conduct and basically be free of the attractions of this nucleus. We call them the conduction band. There is this gap between the conduction band and the valence band, and this is what we call the band gap. Now, there are, in general, three types of materials: conductors, semiconductors, and insulators. And in the case of a conductor, the valence band is actually overlapping with the conduction band, allowing electrons to freely move about and leave the influence of that original nucleus. In a semiconductor, the band gap is not so large that it's impossible, and it only requires a small amount of energy for an electron in the valence band to be transported and basically excited to the conduction band. And for insulators, the band gap is too large for an electron to be conveniently excited to the conduction band.